From now on, we will be working often with the rectangular coordinate system. The rectangular coordinate system, also known as the Cartesian coordinate system, is, I'm sure you have seen this before, is basically two number lines that lie on a plane. We imagine them being on a plane, in that they intersect at the 0 point of each line. So you have here the real line, and you have here another copy of the real line, and they both intersect at a 90-degree angle at the zeros of each. In that point of intersection, we call the origin, and the plane has some properties. The horizontal axis, we always call it the x-axis. Well, almost always, not 100% of the time, but most of the time, is the x-axis. The vertical line is the y-axis, and the plane itself is called either the coordinate plane or the xy plane if we're using the variables x and y, or the Cartesian coordinate system, Cartesian coordinate plane, etc. So it goes by multiple names. The axes divide the plane into 4 sections called the quadrants, and we label them like this: counterclockwise, starting with this corner. So that's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And every point on the plane corresponds to an ordered pair, x, y, real numbers, and we call the numbers the coordinates of the point. The first coordinate is the x-axis, represents directed distance, horizontal distance from the y-axis to the point, and the y-coordinate represents directed distance from the x-axis to the point. All right, and note it's peculiar that we use the notation parentheses x comma y. In that notation, it is used for both to denote a point in the plane. So they could represent the coordinates of a plane of a point in the plane, or it could be an open interval. So how do you know which one is which? Only the context will tell you what we're talking about. Are we talking about a point? Are we talking about an interval? What does that mean? So only the context will let you figure it out. Okay, so I'm sure you have learned how to find the coordinates and plot points. So this is just a quick exercise for you. Try to indicate the coordinates of each of these points: A, B, C, D, E, and F. So pause the video, take a moment, and then write the coordinates. Okay, let's go over them. The coordinates of A, so first horizontally, you to move either to the left or to the right from the y-axis, so that's a 0. And the y-coordinate is 1, 2, 3, 4. So the coordinates of A are 0, 4. The coordinates of B, that would be 1, 2, 3, 4. To the left, that would be negative, so because that's a 0. And then you to move up or down from the x-axis, so there's a 0. So the coordinates of B are negative 4, 0. The coordinates of C, you first go, well, you to move left to right horizontally, you to move from the y-axis, so that's a 0. And then you move down 4, so negative 4. Right? Up is positive, down is negative, right is positive, left is negative. The coordinates of D would be 1, 2, 3, 4. And then you to move up or down, so that's a 0. The coordinates of E, that would be 1, 2, 1, 2. And lastly, the coordinates of F, that would be negative 2. You move 2 to the left and 2 down, so negative 2, negative Okay, one of the basic things that you should know besides plotting points is to find the distance between 2 points. Okay, you should be able to figure out the distance between 2 points if they give you the coordinates. So the Pythagorean theorem is what is used to figure out distance between 2 points, and once you apply the Pythagorean theorem, you have a formula. You get a formula so that you don't have to use the Pythagorean theorem anymore, but it is the Pythagorean theorem that gives us the formula for figuring out the distance between 2 points on the plane. So if you have 2 points on the plane, let's say I have this point right here, x1, y1, and then I have another point over here, x2, y2. Then the question is, how do you figure out the distance between these 2 points if I know the coordinates? Well, we're going to complete this triangle right here. And you see that that is a right triangle. That is a right triangle right there. So we're going to use the Pythagorean theorem on this right triangle. Okay, we need to figure out what is this horizontal distance. But that's not too bad to figure out, because if the coordinates of this point are x1, y1, that means that right here, that is x1. And if the coordinates of that point are x2, y2, that means that this right here is x2. And then that means that this distance is, so what is that? That should be, if this is like 2 and this is like 5, that distance would be 3 because you do 5 minus 2, right? If this is 2 and this is 5, that's 3 because you do 5 minus 2. So similarly, in the abstract, that distance should be the difference, x2 minus x1. And then to figure out this distance, well, if the coordinates of this point are x1, y1, that means this is y1 here, and this right here should be y2. And then this distance right here is exactly the same as this distance right here. And again, how do you figure out this distance? You just subtract. So for example, if that is 2 and that is 5, the difference would be 3. So that would be 3, and you do it 5 minus 2. So this would be y2 minus y1. And then, if we call this distance over here d, the Pythagorean theorem tells me that d squared, which is the hypotenuse, equals this squared plus that squared, or that squared plus that squared. How I started with the x's. So that squared, which is x2 minus x1 squared, plus that squared, y2 minus y1 squared. That's the Pythagorean theorem. And then when you take square root on both sides, remember that in algebra, when you take square root on both sides of an equation, you have to put plus or minus. So that would be d plus or minus x2 minus x1 squared plus y2 minus y1 squared. However, the minus doesn't make any sense because this d is distance. And for distance, we always assume it's positive. So that means the negative we don't use that. So that means the actual answer is x2 minus x1 squared plus y2 minus y1 squared. And that is the so-called distance formula right here. So if you have the coordinates of 2 points, x1, y1, and x2, y2, you use this distance formula to figure out the distance between the points. Square root of, subtract the x coordinates square, plus subtract the y coordinates square. Okay, and when you take the square root of that, that is the distance. Alright, so let's do the first example. Find the distance between the points A with coordinates -2, 1, and B that has coordinates 4 and 5. 4, 5. Okay, so this is not hard if you memorize the formula, which you need to. use it in calculus, you'll be expected to know it. So this distance is going to be square root of, subtract the y's, so be careful with the signs. The order does not matter, just be consistent. So this is my first one, minus -2 squared, plus, I've subtracted the x's, 4 minus -2, and I subtract the y's, 5 minus 1, plus 5 minus 1 squared. And then simplify, and there you have it. Let's see, this is 4 minus -2, that's 6 squared. 5 minus 1 is 4 squared. Um, 6 squared is 36. And 4 squared is 16. So this is square root of, what's that? 42, 52. Square root of 52. And of course, if you can simplify the radical, you should. We're not going to leave it like that. So can we simplify this radical? I think we can, because 52 is 4 times what? 4 times 13. And the square root of 4 is 2. So that means this is going to be 2 square root of 13. Simplified. Box it up. Okay, let's do another one. Maybe you should stop and try to figure that one out. That one is not really exactly the same as number 2. It says find x so that the distance between these 2 points, A with coordinates -2 and 1, and B with coordinates x2 is square root of 17. So basically you have to find x, so that means you're going to have a little equation that you're going to solve and figure out. Okay, give it a shot and then compare with me. Alright, let's do it. Okay, we're going to find x such that the distance between these 2 points is square root of 17. Okay, what is the distance between those 2 points? Well, the distance between those 2 points is square root of, subtract the x's, so x minus -2 squared, subtract the y's, 2 minus 1 squared. That is the distance, and they're telling me that that's supposed to be square root of 17. Okay, so that's our equation then. We're going to have to figure out what x is from this equation. Okay, let's simplify. This is square root of, and then this is x plus 2 squared plus 1 equals square root of 17. Okay, now we need to get rid of that square root. So we are going to square both sides. Okay, we're going to square both sides and see what we get. So we're going to square both sides. Squaring both sides is going to get rid of the square root. So you're going to get x plus 2 squared plus 1 equals 17. That's what we get. Okay, now subtract 1 from both sides, or move the 1 to the other side. You're going to get x plus 2 squared equals 16. Okay, and now just take square root on both sides. Remember that when you take square root on both sides, you do have to put plus or minus. So square root of, I guess we don't really need these parentheses, so let me get rid of them. I mean, they're not really necessary. And so that would be square root of 16. Square root of 16 is 4, so that means plus or minus 4. So then, moving the 2, you're going to get x equals negative 2 plus or minus 4. And of course, we need to figure out, to work out both of them to say what x is. So one possibility is one possibility is a plus. So negative 2 plus 4 is 2. And the other possibility is a minus, and negative 2 minus 4 is negative 6. And you can check that both work. Okay, and that's the answer. Okay, another formula that you should know is the midpoint formula. This is a formula for finding the point that is right in the middle between 2 points. So if you have 2 points on the plane and you join them with a piece of segment, so you have the segment, then the point that divides the segment halfway, the point right in the middle, is called the midpoint. And the formula for the midpoint is very easy to remember. It is basically just take the average of the x coordinates. So you have two x coordinates, x1 plus x2 divided by 2. That's the average of the x coordinates. And take the average of the y coordinates. That's it. The average of the x's is the x coordinate. The average of the y's is the y coordinate. And that is the formula for the midpoint. Very simple. Okay, so first example says find the midpoint of the line segment joining these 2 points. Okay, that is very simple. All you have to do is find the average of the coordinates. So the average of the x coordinates will be negative 2 plus 4 divided by 2. The average of the y's will be negative 5 plus 5 divided by 2. And simplifying, negative 2 plus 4 is 2. 2 divided by 2 is 1. This one gives you 0 over 2, which is 0. And that's all there is to that. Example 5 is a little bit more interesting. It says, suppose that you know what is the midpoint. What are the coordinates of, and you know one corner, what are the coordinates of the other corner? So you know the midpoint is 4, 0, and you know the coordinates of one corner, one endpoint, which are negative 7, 9. What are the coordinates of the other endpoint? Okay, so let's think about that. See if you can figure it out. So, okay, so we know, so let's use the formula. The formula tells me the midpoint, on the one hand, how do you find the midpoint? Well, you just take the average of the coordinates. What points? These two, because these are the corners, these are the endpoints. That's the midpoint, but these are the corners, these are the endpoint. So you take the average of these, so you say negative 7 plus x divided by 2, and then 9 plus y divided by 2. So that's the midpoint. If we knew x and y, then that's how you find the midpoint. But now this is supposed to be the same as 4, 0, because they told us the midpoint is actually 4, 0. So we have these two things being equal to each other. And if they're equal to each other, that means the first entry, the first coordinate, has to be the same as 4, and the second coordinate has to be the same as 0. So that means we set to this equal to 4, and we set to that equal to 0, and that's how we find x and y. So negative 7 plus x divided by 2 equals 4. Well, multiply by 2 both sides, you're going to get negative 7 plus x equals 8. And that gives you what? Moving the 7, you get that x equals 15. Okay, so that gives us x. And to find y, now 9 plus y over 2 equals 0. Multiply by 2, you get 9 plus y equals 0. And then that, of course, gives you y equals negative 9. So that means y equals negative 9. And that's it. We found the midpoint, the coordinates of B. So B is 15, negative 9. We found the x and the y, the coordinates of B.